Hi, everybody. We're going to do the last section in factoring polynomials, and it's just probably a mix of all the different kinds. It's AA.8, so here we go. I'll try to keep the explanations sort of to a minimum. This has 4 terms in it, so a possible way of factoring it is to do factoring by grouping, and we look at 2 separate binomials. And what I'm going to do is I'm going to kind of look at this first pair, 8y cubed and 8y squared, and the 9y plus 9. And what I'm going to do is I'm going to take out an 8y squared out of that first pair. And what's going to be left is y plus 1. And I'm going to take a 9 out of the second pair. And that's going to leave me with y plus 1. Now, the purpose for doing this is that this y plus 1 is a common factor in this first term. This is a term. And in this second term, this whole thing is another term. This is one big binomial right here. And what we're going to do is we're going to take the y plus 1 out of it. And what we're going to end up with is y plus 1. And when it's gone, notice that I have an 8y squared. And I take out the y plus 1, and what's left is the plus 9. Now, if I could, I would factor this second binomial some more. For example, if it was y squared minus 9, I would factor it into two binomials. But that's it. It's non-factorable, the 8y squared plus 9, so we're done. We just have to type it in. We've got a y plus 1 and an 8y squared plus 9. And it looks good. Okay, we're doing factoring by grouping, it looks like, to start with. So it looks like we've got, in our first pair, we've got a 5h squared in both terms. So I'm going to take out the 5h squared. And by the way, normally I'm going to look for a common factor across the entire board, but the only exception to that is when I'm doing factoring by grouping. I'm going to go ahead and not worry about common factors until the end. It just makes it a little bit easier. This is 2h plus 1. What I'm doing is undistributing. If you want to watch the last section, the AA.7, it's about this. I'm also going to take out the 9, and I'm going to be left with 2h plus 1. And now my common factor comes out, and I'm not going to rewrite it. I'm just going to put it in the deal. And we've got 2h plus 1 that we take out of both terms. And then we have a 5h squared plus 9. And that's it. We're done. Okay, now we're looking to what we call a perfect square trinomial. Now, it's not obvious that this is a perfect square trinomial until we do the following. I'm going to go ahead and start factoring it. 9r squared minus 24r plus 16. Now, for those of you who haven't done this yet, go back and maybe take a look at the section on this. I like to stack these guys. Now, what we're looking for is we want to have a product of 16 and a sum of negative 24r for our middle terms. Well, it just so happens that negative 4 times negative 4 is positive 16. And negative 12r, I'm going to cross multiply, and negative 12r gives us our middle term. Notice our middle term is double the product. By the product, I mean if I multiply these two terms together. That's a perfect square trinomial. And so we're talking about 3r minus 4 times 3r minus 4, or just simply 3r minus 4 squared, like that. All right, let's see what we have here. Looks like we're going to be factoring by grouping again. Out of the first pair, I'm going to take a 5u squared, and I'm going to end up with u plus 3 left inside. I'm going to take out a 6, and I'm going to have a u plus 3 left inside. And I'm going to factor out the common factor. And there we go, we're done. We have a u plus 3, and we have a 5u squared plus 6. And that's it. All done. Factoring by grouping again, looks like we can take out a 10r from our first pair, and we have a 2s minus 1. Now, one of the things I want to point out is that what we do is we're looking to get a 2s minus 1 over here. So what do we have to take out to get a 2s minus 1? Well, it's just a positive 7. Sometimes it's not going to be as clear, and sometimes you're going to have to take out a negative. But anyway, there it is. There's our common factor that we're going to take out. And we take out our 2s minus 1. And we've got a 10r plus 7 inside there. And there's our two factors, and there we have it. Okay, looks like we have factoring by grouping again. I'm going to take out a 5z squared out of the first pair, and I'm going to have a z plus 2 left. I'm going to take a 9 out, and I'm going to have a z plus 2. And we're all done already. Z plus 2. And we've got a 5z squared. I want to mention something that may or may not be really obvious to some of you. If you ever have a positive binomial that has no common factors, you can't factor those. It's really common to try to factor something like maybe z squared plus 4, and you can't do it, just so you're aware. Z squared minus 4 is a difference of squares, but a sum of squares usually can't be factored. So there you have it. Looks like we got it, yeah. Got to make sure my variables match up. Okay, factoring by grouping again. We can take out a 5u, and I have a v minus 2. Sorry, that's funky looking v. V minus 2, and plus 2, and it's v minus 2. And we take out the v minus 2, and we're all done. And a 5u plus 2. Okay, now this one is not a difference of squares yet. We do have a common factor of 10. Hopefully you saw it. If you look at these pair, we have a common factor of 10. This can be factored without doing this, but it's really hard. That gives me a 16n squared minus, notice the 10 came out, but there really is a 1 there. Now this is a difference of squares, which means that I'm looking at 4n and 1 and 4n and 1. 1 is positive and 1 is negative. That's how we get our 0 in the middle. Now, a very common mistake is to forget all about the 10. Remember, the 10 is one of our factors. So there's our 3 factors for this. There we go. And that's it. That's completely factored. We have a 10 times 4n plus 1 times 4n minus 1. And I normally separate out the subtraction, but it hasn't given me any problems recently, so I'm going to leave it at that, I guess. I hate getting them wrong because then it makes you do extras. All right, This, hopefully you recognize it. I'm going to write it while you think about it. It's a k squared minus 10k plus 25. Notice that a negative 5k doubled is negative 10k. So k and k, 5 and 5 gives me 25 and k squared. And for the middle, I want it to be negative 5k minus 5k, which is minus 10k. Notice that that middle term is double the product of these two terms. That's a really important idea. It's called a perfect square trinomial, and we just have k minus 5 squared. This one is a little different. I'm going to read it. I have a product of 17 and a difference of 16, and the larger is positive. All of this can be read backwards, and it's all clues as to how to factor u squared plus 16u minus 17. One of the nice things is that 17 is a prime. Oh man, I'm getting some lag. Oh, there we go. Sorry about that. 17 is a prime. So it means that the only way to get 17 is 17 times 1. And we only have a u and a u, so it doesn't matter which one you put the 1 in the 17 with. It does matter which one gets the positive, and we know that the positives win, so the positive goes with the 17, the negative goes with the 1. And you can see the middle terms are negative 1u and plus 17u. And when you add those together, you get your middle term. I probably gave you too much information, but there you go, 17. And we have a u minus 1 separated out so it looks pretty. There we go. Oh, this one's a little more interesting. Now we do have a common factor. The common factor is 7. And I'm going to take that 7 out of all the terms. So take out that 7, and we get 4d squared minus 4d plus 1. And it just so happens that that is a perfect square trinomial. And so we have a d minus 1, sorry, a 2d minus 1 and a 2d minus 1. If you're not sure where I got it, practice it a little bit yourself. I noticed right away that 2d doubled is 4d. So there it is. The way we're going to write it is I'm going to rewrite it as a square. So I have a 7, and then I have 2d minus 1. I'll separate it out there. And then we square it. That's it. This one is not a difference of squares yet. We're going to take out the 6 because it has a common factor of 6 in the two binomials. And what's left inside is p squared minus 16, isn't it? Well, we know that's a difference of squares. So we've got p minus 4 and p plus 4, and the 6 is still there. So there's our 3 factors. Be careful. A very common mistake is to think p minus 4 squared gives you this. It does not. Any square binomial always has a middle term. This one has no middle term because the negative 4p cancels with the positive 4p. So again, way too much information, I know. 6, p plus 4, yep. And how about a p minus 4? There we have it. Looks good. Okay. We have a 5 as our common factor. So we're going to take out the 5. And we have 25s squared minus 9. Hopefully you recognize it, that's 5 times 5s minus 3 and 5s plus 3. And there you go. I decided to do it all in a line for you. Look a little bit more familiar maybe. 5 parentheses 5s minus 3. And how about a 5s plus 3? Looks good. Oh, I like this one. A lot of people have trouble with these because it looks funky. Because remember, a lot of times we look at this and we say, oh, that's a product, and the middle is a difference. Now, some people insist on multiplying the A times the C, and I don't recommend doing that. I like doing it this way, plus 8Q, and I've done it a lot of different ways, and I promise I think this one is the easiest. I've got a 3Q times Q. That is the only way to get 3Q squared, sorry. And to get a 3, there's only one way, 1 times 3 or 3 times 1. Well, 1 times 3 gives me 9Q, I'm cross multiplying, and 1Q. Well, look at that. That has a difference of 8, doesn't it? Now the positive goes with the larger value, and the negative goes with the 1Q. So that means the negative goes here so that I get the negative 1Q right there. And the positive goes right there, so I get the positive 9Q right there. And there you go. There's my factors. I've got a 3Q minus 1. And I have a 3Q, Q plus 3, sorry, Q plus 3. There it is. And a good idea is right at the very end, I'll sometimes check my answer and say, is 9Q minus 1Q equal to 8Q? And sure enough, it is. All right. You probably didn't see it immediately, but 7 will go into all those terms. 63 is 9 times 7, and 12 times 7, and 4 times 7. If you didn't see it right away, it's going to be a lot harder to factor. But I'm going to go ahead and take out the 7. That's going to give me 9t squared minus 12t plus 4. Now this is a perfect square trinomial. 3t and 2 are the square roots of my n's. And if I multiply them and double them, I get negative 12t, if this is negative. There it is. Notice that negative 6t minus 6t, those are my middle terms, gives me my negative 12t. What I'm looking for is I want you to start recognizing the pattern of the perfect square trinomials because it's so important later on when we start solving these things. So we have a 7 parentheses 3t minus 2. You'll notice I insist on separating it out. You don't have to, though. It doesn't count it wrong. And I used a square instead of multiplying it times itself. All right, looks like we have a possible factoring by grouping. Now remember, just because there's 4 terms doesn't mean it's always going to work. In fact, the chance that a polynomial is factorable is much, much lower than you would expect. Factorable trinomials are the rare occasion, not the most common. So anyway, I've got a 5w that I can take out. And we're left with an x minus 2. And I need an 8, and that's left with an x minus 2. And my common factor is the x minus 2. So we've got an x minus 2, and I'm separating it. I know you don't have to. 5w plus 8, are what's left. That looks good. Now what I can do is to check my answer, I could multiply my x times 5w and I get 5wx. My negative 2 times 8 gives me negative 16. And my middle terms, or my inside terms, give me minus 10w. And my my outside terms give me 8x. So I can literally check it where it is. And I know it's right. Looks like a factoring by grouping situation again. Our common factor is j squared, and we're left with 5j minus 4. And this time it is a little trickier. Notice that I want to get a 5j minus 4. And what you need to do is think about what you need to do to that second pair to make it 5j minus 4. And the way you get a positive 5j from negative 10j is by taking out negative 2. So you have to take out that negative. Notice that negative 2 times 5j is negative 10j, and negative 2 times negative 4 is the positive 8. Just something to keep in mind. This almost worked to be factorable some more. Now that's going to happen pretty often in tests. For example, this ends up being 5j minus 4. That's my common factor I take out. When I take it out, I'm left with j squared minus 2. A very common thing in tests is to say, oh, they'll give you a j squared minus 4, and then you have to factor it some more. That happens a lot. I haven't seen it in this particular section, but it may come up when we do solving big polynomials, and in Algebra 2 as well. So there we have it. Let's do 5j minus 4. I made it pretty by separating it. And we have a j squared. And I'll separate this one too, minus 2. Make sure it's the right one. And I could multiply 5j times j squared and get 5j cubed. I could multiply negative 2 times negative 4 and get the positive 8. And look at my middle terms, and I know for certain it's right. It's always good to check on occasion, especially when you're getting toward the end. All right. Hopefully you noticed that we have a common factor in there. It looks like 2 is our only common factor that I can see right away. Yeah. If the last one had been divisible by 3 or 9, I might have been able to factor it some more. But when I take the 2 out, I get 49, which only has 7 as a factor. There's a lot of possible combinations of things, but it just so happens that 2 is my only common factor. And that leaves me with 9w squared plus 42w plus 49. And hopefully you recognize that that is a perfect square trinomial. I keep pushing on that because it's not easy to see sometimes. Because think about it like this. If you take the square root of 9w squared, you get 3w. And if you take the square root of 49, you get 7. And if you multiply these terms, you get 21w. And if you double this, and it's the middle term, then you have a perfect square trinomial. And sure enough, that's what happened. So it's plus and 3w plus 7. Can you see I made a mistake? What is it? You need that 2. What's going to happen to you is later on when we start doing these kinds of problems, you're going to forget about that leading number that you factored out. Because what happens is if this were equal to 0, the 2 would just divide out and we would ignore it. And once you start solving equations, you start ignoring that extra term that you factor out. Anyway, let's go ahead and put in our factors. 2 parentheses 3w plus 7, and it's being squared, isn't it? Oh, I said it's being squared. Come on. There we go. That's it. Let's see. Oh, they sure like that factoring by grouping. I suspect that the AI is looking back at the sections and recognizing that the one that I had the most trouble with was the grouping. I kept putting parentheses where they didn't belong and so on. We've got a 5g squared that we're taking out. And we have a g plus 2. Now remember, I want to get a g plus 2. So what do I have to take out? A negative 38. That's going to give me my g plus 2. And we have a g plus 2, and I'll go ahead and write it, times 5g squared minus 38. Remember, sometimes that's going to be a difference of squares, and you're going to have to factor it some more. We've got a g plus 2 and a 5g squared minus 38. And it looks good. I'm going to go ahead and multiply it to make sure it's correct. Yep. And yes, it is correct. You couldn't see it, but I was actually multiplying it in my head. It's a good idea, and it's always good practice. Now, there is a common factor for this one, and I do need to take it out, unfortunately. I normally would have just jumped right at it and factored it, but you do have to take out the 2. So let's take out that 2, and we get 5f squared plus 24f minus 5. Oh, man. Now, a lot of people are going to multiply the AC method. If you're using it, it does work. It's just that for me, it works on occasion and makes it a tiny bit easier sometimes. But I would say 90% of the time, the AC method, if you know what I'm talking about. Otherwise, I would ignore it, because if you know my method, you're going to find that it's much easier. I have a 5f and an f, which gives me 5f squared. I know I need a 1 and a 5 to get 5. Remember, we're looking for a difference of 24. And when that number in the middle is big, it means that I need to put the 5 with the 5 and the 1 by itself. That's going to give me 25f and a 1f. And sure enough, that does have a difference of 24. Well, that means that the positive goes with the 25 and the negative goes with the 1. Notice I'm just cross multiplying here, if you like to think of it that way. Don't forget to put your 2 down. When you go down, you want to remember to take out that 2 factor. The last step is to put the positive with this one so that it's positive 25f, and the negative with the 1, so it's negative 1f, and we can see that it works. And there's our 3 factors. 2f, 5f minus 1. Come on, there we go. And an f plus 5. Want to make sure it looks pretty. It should be correct. And sure enough, it's looking good there. Okay. When you get to the challenge zone, you generally don't want to make a mistake at that point. Oh, a nice, easy one. Can you do this one in your head? This is a difference of squares, isn't it? So we're looking at 5q plus 3 and 5q minus 3. What's nice about these kind is that there is a pattern. And if you memorize the pattern, it's really easy to just put them in there. There they are. Okay, looks like we've got a possible grouping situation here. Looks like we have a 3nm. So I'm going to take out a 3nm. And what's left inside is an n plus 1. And I want to get an n plus 1. And in order to get that, I have to take out a 2n. Now, be careful. I'm not quite done. And you can see it now, probably. I'm going to go ahead and take out the n plus 1, which is my common factor. Normally, we write it mn instead of nm, but it doesn't matter. Now, those 2 factors are correct, but there's a problem. Notice that there is an n in both of these terms, and we have to take it out. So I normally would say that the first rule of factoring is to look for a common factor and take it out. The only exception to that is factoring by grouping, and that's something I actually learned while doing this section. that it's easier to wait until the end to take out the n. So we have n plus 1. When I take out the n, I have an n times 3m plus 2. And there is my 3 terms. We have an n and an n plus 1. Oh, let's see. And a 3m plus 2. Since I'm almost done, I'm going to go ahead and check it at this point. That's 3n squared m, yep. That's 2n, yep. That's 3nm, there it is. And that is 2n squared, and there it is. I know for sure it's right. Okay. Notice that they both ended in 6. That's a hint. The 6 might be my common factor, but it might be 36 as well. 256 is 16 times 16, I believe. 16 times 16, I believe, is 256. So 16 squared and 36 squared does work. But you need to take out the common factor. Let's see if we can take out a 36. 16. I don't think so. No, I can't take out a 36. I can only take out a 4. So I've taken out a 4. This one is not that obvious. 4, it's hard to see that 256 is divisible by 4, but it is. And it's hard to see that that's the common factor. So you might have wanted to take out the 2 first and then take out the 2 again. So anyway, there it is. That's a 9x squared and a minus 4 goes in there 64 times, doesn't it? Yes, 64. And now I have a difference of squares. I could have started with this. I could have done this, 6x minus 16 times 6x minus 16. The problem is the only common factor is 2 in each of those, and it would have been more work. So anyway, whichever, plus. I like this one, 3x plus 8 and 3x minus 8. And there they are right there. So it was important to take out the common factor. This is not wrong. I could take out the first one, take out the 2, and you get 3x minus 8. Take out the 2 out of the second pair, and you get 3x plus 8. And of course, 2 times 2 is the 4. And that's, either one works. So whatever makes more sense to you. That's 4 parentheses, 3x plus 8. And we have a 3x minus 8. Looks good. Okay. They're just getting big numbers now. Now, 196 happens to be 14 squared. Is 196. One of the things you want to do is memorize your perfect squares up to about 20 times 20, which is 400. Really good practice so that you are able to factor. So it happens that 196j squared minus 280j plus 100 is a perfect square trinomial because I have a 14j and I have a minus 10. But if I just write the 10, notice that 140 doubled is 280. And sure enough, it works out. It's a perfect square trinomial. I do have a negative in the middle, 14j minus 10. And that will give me the correct solution for this. Now, the problem is that there is a common factor, isn't there, in all of these? And taking out that 4 was really hard, but it's really easy to take the 2 out of these, isn't it? Did you see what I did there? I waited until the end. Now, the other time I went ahead and took the 4 out. I think that in this case, it was easier to do it this way. So I have to take out the 2. So I have 2 times 7j minus 5 and 2 times 7j minus 5. Hopefully that's clear. And that gives us 4 times the 7j minus 5 squared. Not as obvious as it could be, but hopefully that makes sense to all of you. So we have a 4 parentheses 7j minus 5, and that is being squared. Now, I am going to have a lot of students who are going to say, oh yeah, Mr. Jimison, I factored that in my head. No, you didn't. You used Math Papa and it factored it for you. Don't do that. You need to learn how to do these yourself, okay? Trust me, I promise. It's well worth your effort. All right. Looks like we have a situation where we're going to do some factoring by grouping. And I could take the j squared out first, just so you notice. You might have noticed that I do have a common factor all the way through, but it's a lot less work to actually take out the 2j to the 4th. We'll see why in a minute, I think. That leaves me with a j minus 1. And I need a j minus 1 over here. And what I have to take out is a 3j squared. Now, I can do two things at once. I can take out the j minus 1. And what's going to be left is the 2j to the 4th, I'll underline it, plus 3j squared. But take the j squared out of that, and you're left with 2j squared plus 3. See what I did there? I promise it's so much easier that way. Anyway, hopefully you can see it. We've got a j minus 1, and we've got a j squared, and we've got a 2j squared plus 3. And I do believe that is correct. Now, I could check it. J times 2j squared is 2j to the 3rd, and that's the correct first term. A negative 1 times 3 is negative 3. J squared is the second term, yep. And my middle terms are correct. I checked it, I multiplied it out, and it is correct. Looks like we got a couple more. Oh, they went kind of the other way. They went to easy, didn't they? The thing is, 24 has lots of factors. And, you know, people tend to look at this and they go, well, wait a minute. How am I going to get an 11 from 24? That's an even number and has lots of even factors. Well, by the way, something to think about is that there is no way that 2 times 12 is going to work, because 2 and 12 are both even. And when you add them together, you are going to get an even number. Remember, when you're looking at this kind of trinomial, that last number is a product and the sum is 11 and they're both negative. So that's what those signs and numbers tell us. Now 4 times 6 also will not work, because 4 times 6 is 24, but that does not have a sum of 11. And hopefully you see it now. It's the one in the middle of those, 3 times 8, which does have a sum of 11. And of course, we're talking about d minus 8 and d minus 3. What you want to do is practice until this becomes easy to do in your head. And it does take some practice. You may have to practice even more than what's here. D minus 8. And we have a d minus 3. There we go. And we're almost done. Looks like we have 2 left. Looks like we have a common factor of 5. So I'm going to factor out the 5. And I have 2z squared plus 17z minus 19. Now I want to remember to bring down my 5 And I'm going to go ahead and do my stack here. The only way to get 2z squared is to multiply 2z times z. And the only way to get 19 is 19 times 1. But I want to get a difference of 17. Now, a lot of people say, well, 19 and 1 don't have a difference of 17. But keep in mind, I've got a 2 there. Here's how it works. Look what happens if I put a 19 and a 1. That is going to give me 19z when I multiply it across, and 2z. And look at the difference. 17 is the difference between 19 and 2. The positive goes with the 19 and the negative goes with the 2. So I need the negative here so that it gets to the right place. And I need the positive here so it goes with the 19. And there it is. You can check it. You can multiply that out and you'll see that it works. But look, we chose the first and the last to make them work. And the middle terms are 19z and minus 2z, which is 17z. So we have 5 times 2z plus 19 and a z minus 1. And go ahead and erase it so we can see it. There it is. Very pretty. Okay. Looks like we have one last one and then we're done. Okay, guys, looks like we have a factoring by grouping. Got to be careful and not submit yet. Looks like we've got a 3xw we can take out. 3xw out of the first pair. That's going to leave me with 4x minus 3. And I want to get a 4x minus 3 over here. And the way to get that is by taking out a positive 2x. And I'm almost done. I take out the common factor. I've got that 4x minus 3. And I'm left with 3xw plus 2x. I'm going to go ahead and write it. I know I don't have to. I could have taken the x out of that. It wasn't that hard. Now I have a common factor of x. So I'm going to take that x out. And we have 3w plus 2 after I take out the x. And there are my 3 terms. We have a 4x minus 3 just making sure. Since it is my last one, I have an x. I don't think it'll matter if I stick it in the middle. 3w plus 2, close my parentheses, and I could go ahead and multiply these. So 4x times 3w is 12xw, and I'm multiplying it by x, which does give me the right one. For my middle term, I get a minus 9wx, yeah, plus 8x squared, yeah, and a minus 6x. And it is correct. It's absolutely correct. And I hope you'll do yours and get your math trait. And I will see you back again in the next section, which is solving. Yay. Bye, everybody.